Hello everyone, mic test. I was almost the first. Hello to Polly, Elise, Cherry, Wan Yi, Michelle, Stonks. Okay, wait. Okay. So looks like everything's set. Kind of, Elise. Okay, so I guess I can begin now. Right, okay, use this one. So I'm going to be using a slightly different setting. Hello to everyone. Good evening and welcome to tonight's Facebook Live session brought to you by Maths Heuristics. So if you haven't already, please go to www.mathsheuristics.com/blog to download the notes. And also, this is where we will archive everything. Okay, when we share, we really share. So this happens every Wednesday at 8 p.m. until your SA2s are over for the P4s and P5s. So you notice that this session isn't meant for the P6s because right now you're going to have to take a break and rest your mind for tomorrow's final battle. Okay, so just take this as a revision. We won't be covering anything too heavy for the P6s. And secondly, this will be more of a revision if you are looking at it. But I hope you do take a break first. Probably you feel it tomorrow afternoon or something. Okay? So a bit about myself. I'm the curriculum specialist here at Maths Heuristics. My name is Kevin Huang. So I've been working here since 2011. After the end of this year, it's going to be my 9th year in service over here. So it's been a pretty long ride, and there's still a long way to go. Okay? And over here, the content that we are covering is from the Mastering Heuristics series. It is a set of books that my boss and mentor has written, and today's session will be based heavily on the unit transfer method. Okay, I think this is good because, hang on. So he written this back, first written and published this way back in 2009, and the second edition since then. After all the criticism and refinements, he published the second edition in 2010. And what does this book consist of? It consists of, okay, let's say that I flip to a random page like this, explaining on case 1, case 2. It consists of explanation. Well, it's very hard to see the camera from here. It consists of the explanation in a one-shot format. And if you like to find out more about how the solution was derived, the thought process will be explained over here in detail, along with confusion alert to warn you about common pitfalls that students usually make. Okay? And also, to increase to get kids to like to read our books, we have also developed the mobile app and web video for easier viewing, because we understand that this book itself can be quite technically heavy. So we've distilled it into web videos and the mobile apps. Okay, so they will be covering on the unit transfer method, part 2. Okay, so these are the common kinds of problems that you need to know, because these are the problems that are very easily scorable when you have the knowledge. Okay, so today I'm going to give you that knowledge. Hang on, have I changed the screen already? Okay. Yeah, anyway. Yeah, I know, Elise, you're still here. Okay, Elise. Later I'll share a Chinese saying with you that I just recalled yesterday. Yeah, my face is very bright right now because I've changed the settings. Now, Area 51 didn't really happen. Okay, but anyway, okay, let's begin now. Memes. I don't have memes for you today. Okay. In a fruit stall, 2/5 of the fruits are apples and the rest are oranges. So the next day, 63 oranges were sold. 1/4 of the remaining fruits in the stall were oranges. How many more oranges than apples were there in the stall at first? So over here, okay, let me change the color first. Let me change it to something brighter. Okay, 2/5 of the fruits means that your number of fruits can be, you can draw out one long bar to represent your number of fruits, and they can be all cut into 5 equal portions. 2 of them are apples, and the rest are oranges. So this will be 5 minus 2 to give you 3 blocks over here. Okay, this was before anything happened. Okay, the next day, 63 oranges were sold. This is the change. And at the end of the day, 1/4 of the remaining fruits in the stall were oranges. So 4 goes to your remaining fruits. This 1 refers to your oranges. Okay, make sure you are at a point in your house where you're very close to the Wi-Fi router. Okay. So okay, you got apples and oranges before, change, and after. Let's set up the table and tabulate the information. Okay, we've just interpreted everything so far. So let's organize the information a little. There are 2 blocks of apples over here. There will be 3 blocks of oranges over here. So in the model form, this is what's going on. You got 2 blocks representing apples, 3 blocks representing oranges. So the next day, 63 oranges were sold. 1/4 of the remaining fruits in the store were oranges. So there will be 1 out of a total of 4 blocks that are oranges, which means that the remaining 3 would have to belong to the apples. Okay? Okay, so once you got this, I'll give you about 15 seconds to write it out. Okay? Yeah, please don't spam the thing. Don't spam the chat. Don't distract the others. Okay, so once you got that, let's look at the change over here and try to determine what to do next. So we can observe that there is no change for your apples. I don't know what is yeet method. Maybe you can demonstrate to me next time. Okay, so these 2 blocks and these 3 blocks here has to be of the same length. Okay, and we want to make them the same so that we want to make them into the same length so that we can compare everything uniformly. So that's the rationale. When we do this, this becomes 6, this becomes 9, this becomes 6, this becomes 2, and this becomes 8. Alright? Yeah, you need to make apples the same. Okay, when we say that you want to make apples the same, we are always looking for the lowest common multiple between 2 and 3, because 2 blocks here can also be cut into 3 small blocks over here. So you want to cut them all up into the same size. Somewhat like this. But of course, if you try to draw this out physically, it's going to be quite time consuming. Secondly, it's quite difficult to really draw it out with unfriendly numbers. Okay? For me, I mean, I've been doing this for a long time, I can draw it quite naturally lah. Okay? So once you have this, the next thing you want to do is to find out the value of 1 unit first whenever possible. Okay? Here you can see that from 9 there's a minus 63, and then you have 2 remaining over here. This means to say that these 9 blocks from 9 units down to 2 units. Okay? Remember, the very fundamental thing here is you want to observe the change in units. And versus the change in value. Okay? You will see that from here, 9 units down to 2 units, there is a change of 7 units, which is 63. Okay? So 1 unit here will be 73 divided by 63 divided by 7 to give you 9. Okay? So once you have that, you want to find out how many more oranges than apples were there in the stall at first. So over here, what does this 9 represent? This 9 represents the value of one of the blocks that has been cut up into the same unit. So we will need to compare between 9 units and 6 units here. So that difference will give us 3 units, which is 3 times 9. That will give us 27. Then this will be your answer. Okay? So the main confusion here that arises, some students, what they do is they take 3 and minus 2. No, you see, in this, okay, if I were to zoom in here, okay, can you see that the 2 and 3 actually represents the big blue block, whereas one of these small ones represent the 9. Okay, it's a bit messy. So that's the confusion alert that I want to point out. Because in ratio, you usually don't label the numbers, you don't usually label what they are. So you have to be very aware of what you are doing. All these things, you want to have a strong foundation in your models first, so that when you transit towards more abstract methods, you know and are aware of exactly what you're doing. Okay? Okay, it is, don't go and make fun of people's name. Okay, is everyone clear on this? If you're finding that the Facebook video is a bit blurry, right? You try to move to the point in your house where your Wi-Fi is installed. Your Wi-Fi router where it is installed. Try to move towards there. Okay? Could be a connection issue that it cannot stream fast enough. Okay, so let's move on to the next one. Okay, a lot of you spam the like button already, even though I kind of forgot to ask you to do so. On my end, it's still okay, so I'm not too sure what happened. Okay, the next one. Okay, by the way, this is what we call a single unchanged quantity. Whenever possible, the rule of thumb here is to look for a repeated identity. In this case, it's the apples that remains unchanged. And try to make them the same first. You always want to try to work with a singular unit as far as you can for primary maths. Okay, so for number 2, the ratio of the amount of Paul's savings to Benny's savings was 3:5. Okay, let me use blue for this. So this was before anything happened. I have 5 questions, so I may overrun a bit. After Paul received part of Benny's savings, this is the change. The ratio of Paul's savings to Benny's savings became 9:7. And this is your after. So the amount of savings that Paul received from Benny was $24. So this seems like a bit strange way of phrasing, but we can identify that this is the change. What is the total amount of savings that the boys had? Okay, so to deal with this, let's tabulate the information first. Okay, draw your BCA table, then I'll give you about 10 more seconds. Okay, so here's what we can do. For Paul has got 3, Benny has got 5. Paul received $24 from Benny. So Benny is going to Benny's amount of money is going to decrease by 24. Paul's money is going to increase by 24. And then that ratio becomes 9:7. Correct? And once we have this here, we want to try to look for an unchanged quantity. So you want to look at the change row first, because the change is the most important element in a before and after scenario problem. Okay, without the change, there is no before or after to speak about. Okay, go and think about it. So look at the change row first. Over here, we observe that there's the same number with opposite signs. So this would mean to say that this is a total unchanged quantity. Okay? The other way you can reason this out is that this is also an internal transfer, but it's not only just internal transfer that allows this to happen. So once you've identified this, you want to extend out a total column first. Okay, try not to preempt the problem. You want to go step by step and see what you have first. Okay? See what you're given first. Look at the situation before you charge. So, okay, once we've established this total column, we can, of course, add up these two. 3 plus 5 will give us 8. 9 plus 7 will give us 16. And because your total remains unchanged, your 8 big blocks over here will be the same as the 16 small blocks over here. Once you've identified that, we can make them the same. We want to get them to the lowest common multiple. And the lowest common multiple is the smallest number that can be divided by both 8 and 16. Smallest possible number will be 16. So at the primary level, how do you find the lowest common multiple? If you're not sure, list it out. Multiples of 16, multiples of 8. List it out. Okay, the prime factorization is something that you'll learn in Sec 1 or Maths Olympiad. So if you don't know what's prime factorization now, it's still alright. So multiply this by 2, you get 10, and you will get 6 over here. So once you have that, you can now compare from 6 units up to 9 units. What was the change in units? The change in units is 9u minus 6u, 3 units. And 3 units is 24. Remember, change in units here from 6 to 9 is the same as your change in value. So when we got that, 1 unit will be 24 divided by 3 to give you 8. And over here, let's look at the objective. What was the total amount of savings that the boys had? That will be 16 units. 16 units will be 16 times 8 to give you. As you can tell, I don't refer to my answer key. Okay, the answer here will be $128. Okay, the answer key, personally, I know how to solve it, but I feel like relying on an answer key is like too scripted. I prefer to explain it logically and with the flow. Yes. Peter, wait Eunice, Maria, Peter, Polly, Erica, Jacqueline, Lena, Elise, Apana. Yeah, okay, you got it. Don't worry about it, Wykit. Okay? Okay, you've got it. Please spam the like button. Yeah, it's 128. Okay, okay. All the angry face. How do you pronounce Erica? Yeah, Geraldine, you got it. Okay, so this structure is on total unchanged quantities. This will make your life a lot easier if you make something unchanged first. If not, you'll end up with having to apply two variable concept, which can be quite tedious. Okay? Arisha. Okay. Yeah, I always pronounce that CIA part wrongly. Okay, I got one student in my online lesson. Her name is called Gray She. At first, I pronounced it as Gracia. Okay, okay, let's go on to number 3 then. Billy had $125 more than Jamie. So this was before anything happened. Both of them spent the same amount of money to buy a wallet. That's the change. And as a result, Jamie now has got half as much money as Billy remaining. So allocate your units first. 2 goes to Billy. If we use 2 blocks to represent Billy, then 1 block would represent Jamie's amount. Okay? So given that the total amount of money that they had left is 2.5 times the cost of the wallet, one very important thing in unit allocation is to convert this to an improper fraction in its simplest form first. So this becomes 25 out of 10, and it breaks down to 5 out of 2. So the money that they had left is 5, the cost of the wallet. Okay, I cannot go to the left from here. It's going to come all the way here, and then it's going to come all the way here again. Okay? So once you got that, you can now set up the PCA table between Billy and Jamie before, change, and after. Okay, is it okay now? Because mine is still working fine. My live stream, the way I see it, is still working fine. Yeah, Agnes, this is difference unchanged. Okay, so once you got this ready, the next thing you have to do, okay, allocate your units first. Jimmy has got 1, Billy has got 2. This is your after, so start from here first. And the next one is, both of them spent the same amount of money to buy a wallet. So this is minus question mark, minus question mark. And you know that the difference at the beginning, where B has got more than J, the difference will be 125. Okay, so at the end of the day, Billy has got 2 units, Jimmy has got 1 unit. And that difference here is 1 unit. So you can observe that inside the change row, you have the same numbers with the same signs. Is difference unchanged? Okay, yeah, let me spell out the whole thing. Okay, to drive home the point why this is the case, this one may not seem very intuitive at first, especially for parents. Think of it this way. Okay, they both have a certain amount at the beginning. If you are to cut away a certain portion that is the same for both of them, that difference will not move. Okay, and if you are to add the same amount for both of them, that difference here doesn't move at all. Okay, and this is very the trick here is, if you are drawing models, you want to do it on the left side when you are taking away an equal amount, or when you are adding on an equal amount. Okay, this will make the clue a lot more easy to spot, right? So once you have that, we can see that these two are equal. We want to make them the same. If 1 unit is 125, then 2 units will simply be 125 multiplied by 2. Okay, so now we know how much they have at the end. What other information can we make use of? Let's look at it. The total amount of money they had left is 5 out of 2, that of the cost of the wallet. Okay, so let's just represent this like this. You have got 5 blocks remaining, and the wallet will be represented by 2 blocks. The amount left will be 250 plus 125 to give you 375. Correct? That is the total that they have remaining, which is over here. No, Arisha, you didn't miss anything. You didn't miss much. So once you have that, if 5 blocks represents 375, then we just divide this by 5 to give us 75 first, and then we can find out the cost of the wallet. Hang on, is my face blocking it? So we've established that the cost of the wallet is 150. You want to find out the amount of money Billy had at first, which is over here. You can organize your information, you can retrieve it more easily. So if this is the case, this is minus 150. So think of it this way. Something minus 150 gives you 250. So that something would have to be, you have to work backwards in order to attain it. And this will be 400. So the answer here will be $400 at the beginning. Okay, Maria, you got it? Yeah, I'm very good with names when you teach me how to pronounce it. Okay, if not, it'll be a total disaster. No, Peter, the one that you obtained is for Jimmy. Yes, Arisha is 400. Geraldine got it too. Okay, I'll give you all some time to write this down, don't worry. Okay, wait lah. Okay, so I think we are still right on schedule. Hello, Janet. Okay, so is everyone done? Yeah, Belinda, you got it too. Tomorrow is the start of PSLE, yes, I know. If you're P6, I think you should be resting by now. View this tomorrow or something. My view count doesn't really matter. Actually, I don't really care about it. Okay, got it. Number 4. Now, Andy had some pencils in 2 boxes. So after transferring 3 out of 17 of the pencils in box B to A, the number of pencils in box A becomes 27 of the number of pencils in box B. Find the ratio of the number of pencils in box A to that of B at first. Yeah, tomorrow is the start of PSLE. Tomorrow is the English paper. Okay, so anyway, let's talk about this. So, okay, the first statement is to set the total number of pencils. So within this 3 out of 17, within this little fraction itself lies a lot of information. It contains information about before, about the change, and the after, albeit in a very indirect manner. A lot of it has to be inferred, but we can definitely do that. Then later on, the number of pencils in box A becomes 27, the number of pencils in box B. Okay. So this is definitely for your after result. Okay, so why did I say that within this 3 out of 7 itself lies your information about before, change, and after? This is something very critical that you need to know how to do on your own. So let's look at it this way. 3 out of 17 of the pencils in box B means that box B at the beginning, okay, let's draw the before, change, and after table first. Okay, I'll give you some time to draw it out. Yeah, now it's kind of lagging. Okay, but anyway, you can see that for B, right, you have a total of 17 units. You move 3 units over to A. So you would be left with 14 units here. Your A, you're not too sure what it is at this point. Okay, but you also know that this is 2, the ratio at the end is going to be 2:7. You're going to have 2 pink blocks representing A. You're going to have 7 pink blocks representing B. So how do we get from 7 to 14? We would have to multiply it by 2 units here. So this now becomes 4 units in total. Okay, you have to make everything into the same unit first. And once we have that, we can observe that you can work backwards directly from here. Okay, if you are familiar with example 2 earlier, you would also be able to say that this is a total unchanged quantity because you have the same numbers with opposite signs. So the total remains unchanged. Okay. So once you got that ready, you can already answer the question from here. What is the ratio in A to B at first? That ratio will be 1:17. Okay, very straightforward from here. But the hard part I realize is that most students, when they see this 3 out of 17, they kind of freeze or they kind of get intimidated. No, just calm down and think heuristics. Calm down and define out what this is first. Okay? Yeah, Arisha, Eunice, you got it. Peter, you got it. Yeah, that's the main idea. You all prefer with light on my face or without light on my face? No, Maria, it should be 1:17. Sorry about this. I'll try to look into. I'll try to look into what's causing the problem. Okay, I think my settings is a bit too high quality already. Light with no face. How do you get the 1 unit in green? Okay, you see, you have 4 units here, right? You have 4 units here. Something after receiving 3 units gives you 4 units. What was that something? So here you want to work backwards. You want to reverse that flow. Okay? Why keep which part you don't understand? Like at night you on the light, yeah. Actually I prefer it this way. Okay? Okay, so anyway, I think let's move on to number 4. Okay, there were some oval and circular shapes in a box. Max, okay, there you go. This one is the last one already. Please change this to number 5. Yeah, I just experienced it too. Okay, there were some oval and circular shapes in the box. Max put 48 more circular shapes in the box. Then, 2/5 of the shapes in the box were oval shapes. Okay, why later I explain to you. Okay, then 2/5 of the shapes in the box were oval shapes. Later, Max put in another 135 oval shapes into the box. 3/5 of the shapes in the box were oval shapes now. So how many circular shapes were there in the box at first? Right, this is going to be one of the harder types of problems that you'll see. Model can still solve this, it's just going to be a lot longer. It will take a lot longer. Okay, so let's see how we can do this. This was before anything happened. Max put in 48 circular shapes, then there is an after result. 4/5 of the shapes in the box were oval. So what this means is that 3 goes to circular. Max put in another 135 oval shapes into the box. There is another after here. 3/5 of the shapes in the box are now oval. Okay, Destiny, are you close to your router? Okay, I think my quality a bit too high already. I need to tune it down. So anyway, once we've got that, okay, here you don't know what you had at the beginning. So let's trace out the entire flow first. You put in 48 more circular shapes. Then 2 out of a total of 5 were now oval, which means that your circular shapes has to be 3. Then after this, you see that Max put in another 135 oval shapes. So now 3/5 of the shapes in the box were oval now. So 3 goes to oval, 2 goes to circular. Yeah, like it, I think we did something like this before. Not the exact same question, but something like this. Okay, so now let's stare hard at this first. We've defined out the whole situation. What can we do next? BCACA. Yeah, we did something like this first. What can we do from here? Yeah, let me check something first. Can you all see anything, or did it hang? Okay, I think I have to give up the recording first. Okay, so calm down everyone. Let me try to find out what is the reason. What about now? Because on my end, I don't really see anything. Okay, right, how about now? Leh? Okay, now I think there's a lot less laggy also. Okay, one of these days I'll find a time to figure out how to optimize all the settings. Sorry for that. Anyway, what can we do from here? What can we do from here? Anyone? Okay, so over here, the main thing that you need to look at is this portion. Because within this portion itself, let me try to. When you look at this portion, over here, you will see that there's no change for your circular objects. Okay, you can make them the same by getting them to 6. Multiply this by 2, multiply this by 3. And then you will see that to maintain all the equivalents, everything else has to be multiplied. Okay, so once you got that ready, from 4 units down to 9 units, change in units is 5 units. Change in value is 135. So 1 unit here will be 135 divided by 5 to give you 27. So the next thing is, how many circular shapes were there in the box at first? So you know that you could have 6 units over here. 6 units would then be 6 times 27 first to give you 162. And you want to minus off 48 because you want to find out what was there at first. Something plus 48 gives you 162. So that has to be 162 minus 48. So this will be 114. And this will be your answer. Yeah, the main thing you see why I paused there for so long is to force you to think first. I want you to think about what can be done. Okay, you want to think about what you can do first. Because this is an advanced single unchanged quantity. With 2 changes, as you can see. Okay, a lot of you got it already. Pretty good. So this is the more advanced type. Okay. So I've come to the end of my presentation. I'll give you about another 15 seconds before I talk about some other stuff. Okay, so now on the Mastering Heuristics series, this unit transfer method session 2 was based off the first few chapters of the unit transfer method for P5 and P6. So you can get them from mathsheuristics.com/learning tools. Hang on first, let me try to type it out. Okay, let me try to type this out first. Okay, I have to censor my thing a bit. Oh, okay, thanks to today's session method for P5 and P6, I've also found out so you can acquire them you can get them from mathsheuristics.com/learning tools. Hang on first, let me try to, why can't I type in anything? Yeah. So right now show my face first, because I cannot let you see certain data inside my Facebook page. Why can't I type anything? Yeah. So right now show my face first, because I cannot let you see certain data inside secret my data. Data that's so secretive that if you know it, I have to silence you. Hang on, how come I can't access it from here? Stonks. Yeah. Why can't I type anything? Stonks. Yeah. Why can't I? Well, this is very strange. Hang on. Let me type out the link first. Why can't I type anything? Well, this is very strange. Okay, I'm glad you like it, Joanne. Let me type out the link first. Why can't I type out anything? I want to comment, why I cannot comment? Okay, you're welcome. Why can't I type anything? Well, this is very strange. Okay, I'm glad you like it, Joanne. Let me type out the link first. Oh, this is bad. Why can't I type out anything? Yeah, it is. I remember that. Okay. Hang on, Okay. Wait, typed out already? Yeah, I'm here. But why can't I pin this? Why can't I pin this up? Okay, yeah. Yeah, okay. Yeah, that's done. Okay, so you can purchase this from here. This is what you will get when you purchase this from us. The first one will be on the hard copy book. The second one will be on the ebook while you're waiting for the hard copy books to arrive. Ebook version. Third one will be on the mobile apps. Currently, this is only available for iOS and it's currently under review at Google Play Store for the new version. Then number 4, this will be on the web videos. Explanation. Okay, so coming back to the point for Elisa, there's this saying called 天下无难事. Haven't written Mandarin Chinese characters in a long time. Okay, you're welcome, Stephanie. Welcome, Eunice. Let me type in Chinese. Okay, wait. Let me try to find out what's wrong with my thing first. What does that Chinese thing mean? Okay, it means that under the, okay, literally translated, okay, under the skies, there is nothing difficult. It is only afraid of people who have heart and determination. Okay, but my Chinese is not that good, to be honest with you. But all these little sayings are the things that have guided me throughout my life. Okay, so this is something that I just recalled yesterday because right now I'm like dealing with multiple projects that requires a lot of concentration and a lot of time to handle. Okay, and then at the same time also there's also inquiries from the P6 coming in, from our P6ers coming in, that then we got to deal with that at the same time. Okay? Yeah, welcome 别客气 Arisha. Okay, if you are P6 you better stop and go to sleep now, okay? Sleep, go and sleep already. We'll meet each other again. Maybe next year you can drop by, or after your PSL you can drop by to say hi when you're more relieved. The book can be purchased online or it can be bought at our office at 195A Thomson Road. Gold Hill Center. Singapore 307634. Okay. No, I don't have memes for you. Okay, you want some memes? You let me see whether I can find it or not. Okay, let me see whether I can find it or not. There's one I came across quite funny from Channel News Asia today. So I'm switching to this mode first, so that you don't scroll through my page. Where is it? Where is it? Okay, you're welcome, Brian. Okay, this is something that just came in today, I believe. Let me look for it first. Where's the post from China News Asia? Okay, got it. Okay, here, don't know whether you can see it or not. This guy found something called a red-bellied black snake and names it Chonk. So it's gonna be Stonk's best friend. Okay? Arisha, go yeet that paper tomorrow. Okay? Make it go oof. So this is the Stonk's new best friend. Snorlax has forgotten amnesia. Yeah, okay, you all better go and sleep now, okay? P6. Yeah, I don't want to hold you back. Okay, so anyway, I think I better call it a day already. If I don't leave, you are going to. You're not going to leave either, so I think I better leave first. Okay, have a good night. And see you all soon. Okay, bye bye.